In this recording sizobe siphendula nangu question 6. It's about the nature and properties of waves. Sinama waves I2, sina two types of waves, the longitudinal as well as the transverse wave. So lana we are given a transverse wave, and then bese babeka nama alphabets nyana, like bamakama points la sino R, sino S, sino T, sino U, C, and then the length B, sibe no A, and then sibe ne lokanje ne amplitude. The amplitude, you need to know wonke lama terms as well as lokanje or the parts or the components ayenza transverse wave. So the diagram below represents the pattern of waves with frequency 30 Hz moving from left to right. So the wave will move up in this direction and this direction all the way up to the right. Thanks for tuning in, guys. Check out the description box. Ngishiyama links for other recordings for this question paper. Alright. Asipho ukuthi basiphetheleni ke la. Basibuzana kahle kahle. But 6.1, define the term transverse wave. What is a transverse wave? It has to do with the propagation of the wave. A wave where the movement of particles in a medium is perpendicular to the direction of the propagation of the wave. Let's say sinentambo la. Na intambo ukilibone uyibambile la. Uthemba uyibambile naye ngapha. Right? Abangani bakho la. Bangani bakho. So nakayibambile ukilibone uzothatha le ntambo le, ne? Ayilo kanje, ayiphakamisele phezulu bese ayibuyisele phansi futhi, right? After qeda ukwenza lokho, this is what's going to happen. Iyenza so le ntambo. Whoop. You form a pulse. The more uloka ukilibone nangabe uyisa phezulu naphansi for, let's say, for several times, eventually izowenza something like this. Izothi whoop 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 whoop. Laqeda uluka uthemba on the other hand, or on the other end of the lokanje, on the other end of the rope, uzofila lama pulses, isandla sakhe sizovibrate nyana. So this is an example of a transverse wave. Mawuthatha ukubheka, the particles of the rope are the wave. Okay, a wave where the movement of particles in the medium is perpendicular to the direction of the proper. So now my particles they are perpendicular to the direction of what? Of motion of the wave. Yes, so this is an example of a transverse wave. Transverse wave nangabe uthatha ilitsha uliphonse emanzini, unokubona kunokufomeka ama ripples nyana. So lawo ma ripples, it's an example of a transverse wave as well. A common type of transverse wave is what study like grade 10 electromagnetic radiation. It's the radiation from the sun. So now it's an important transverse wave. Okay, this is the definition. Go 6.2, but he label points A, B, and C. Alright, 6.2, upu A. Okay, upu A now A. Now B and now C, but it's labeled lama points now. A win something called a throw. It's the valley or the lowest point of the transverse wave. The highest point is with C. It's the crest or the peak of your wave. Bese siyabuya siba no B. It's the distance from la crest number 1 to crest number C. What is B called? It's the wavelength. The wavelength is always the distance between our points are in phase, right? So this is the wavelength. A throw, so okay, not physically, but some debate over this. Point A is not called a throw, but we had this discussion over a sine wave in mathematics. But this is not a throw. Yini throw. Uzenzela amagama wakho la. No, this word exists. Throw. It's this point. It's the lowest point on your transverse wave. 6.3. How much time has elapsed while the wave moved from R to T, from R all the way up to T? I think it's about time so much. Ni erase la. So ngifuna the time that lapsed when the wave moved from R all the way up to T. Yes, all the way up to T. Mawuthatha ukubheka la, U-R no T, they are in phase. Yes, they are in phase. Why? Ngoba they are being separated by a wavelength. U-B no C, they are in phase, separated by a wavelength. A, now this point, they are in phase, they are separated by a wavelength. S no U, separated by wavelength, right? So in order to calculate this isikhathi, since we are given a frequency la, we can use the formula AT. T is equal to 1 over frequency. Yes, so we just substitute this frequency, then it was nigeza the time. Actually, frequency it, there's 30 waves moving at a point per second. There's 30 waves moving at a point per second. So sifuna ukwazi ukuthi i-wavelength eyi-1 ithatha isikhathi esingakanani to move, right? Per second equal to 1 over 30. This is equal to 0.03 seconds. So this is our answer. With 6.4, our points R and S on the wave in phase. Our points are in phase, are being separated by a wavelength, or by a complete wave. By a complete wave. So bega R no T, they are in phase ngoba they are being separated by a complete wave. A wave uyibona ngani? It's a complete wave, like back. Udinga a crest, udinga nani ne throw. Then ubanani ne complete wavelength. So in this case got B, this point le, now this point le. This is also a wavelength, right? It's a wavelength, it's a complete wave, right? It's a complete wave and they are in phase. Ngoba umejara from crest to crest. Nangapha, throw to throw, uzothola a complete wave. Uzothola a complete wave, or our points are in phase. So basically, nasithi our points are in phase, they should be separated by a wavelength. Is R and S, are these points R and S in phase now? Yes? No? Of course it's no. Why? They are not in phase. They are not in phase. We are the distance between R no S. It's so short ngale is not equal to a wavelength. It's less than the wavelength. So therefore city no, they are not separated by a wavelength. Singasho njalo na. by a wavelength. 6.5, last question. Calculate the speed of the wave. Okay, there's a formula esisebenzisayo for calculating the speed of a wave. It's V equal to the frequency times the wavelength. Yes, so you need two quantities, like udinga frequency udinga nani ne wavelength. So what is the frequency? 30 siyamfaka, wavelength 4 meters basiphe. This length delay, it's what we call the amplitude, measured from the axis of the wave to the lowest point or the highest point. This distance is 2.25. This one. Now this distance is 2.25. Now this one is 2.25. So see the frequency with 30. Now the wavelength, we are only interested to go 4 meters. So the 4 la. So 30 times 4, this is 120 meters per second. Noma ungayibhala so still correct, 120 meter per second. This is one and the same thing. So now I answer it, guys. And the last question, like question 6. Oh yeah, so our lesson is ophelela lana. I hope you enjoy it. Makhohlwa ukulike, ukushare nokusubscribe. So for now, guys, asibonane on the wavelength. Bye bye.